Scientists have found that the red planet once had water on it. Mars is one of the most researched objects in the universe. The region is remarkable for being the only potentially habitable planet in the whole universe so far. With this latest discovery, scientists are still curious about this planet, whether or not it might or has ever sustained life. The baffling discovery of salts in Mars has scientists scratching their heads. Mars, the so-called red planet, is showing its true colors, and it's a red alarm. Is this a clue for life? Is it conceivable that we've finally found a new home to live in? Is it the aliens or something completely different? Welcome back to our channel, and keep watching till the end while we answer these terrifying questions. There's a lot of evidence that Mars formerly had liquid water, and more data is being collected all the time. However, this information doesn't provide us with a complete picture of Mars' past. But Mars once had rivers and ponds which could have provided a home for microbial life billions of years ago. That water evaporated as the planet's atmosphere thinned over time, leaving a frozen desert for NASA's Mars Reconnaissance Orbiter, or MRO, today. MRO features two cameras that are perfect for this job. The Context camera enables scientists in mapping the region of chlorides using its black and white wide-angle lens. Scientists use the High-Resolution Imaging Science Experiment, or HiRISE color camera, to zoom in on details as small as a Mars rover from orbit, allowing them to observe details as small as a rover from space. Two Caltech researchers, Ellen Leask and Bethany Ehlmann, helped create a clearer picture of Mars' past by predicting the likely behavior of the last liquid water on Mars and determining when it stopped flowing in the last week of January. Tracing salt deposits on the Martian surface was their secret. Many different salts have been discovered on Mars' surface, but the ones of importance here are chlorides, which most likely contain table salt sodium chloride. These are particularly useful because these salts are most easily soluble in water. As a result, if there is any water nearby, those chloride salts will dissolve in it. Any deposits of these salts that are currently present on Mars' surface were deposited there as the planet's last water evaporated. Detecting chlorides from space, fortunately, is not difficult. They have a unique spectral signature shared only by a few other compounds such as diamonds, which are unlikely to be found in considerable quantities on Mars' surface. As a result, the researchers used data from the Mars Reconnaissance Orbiter to map the existence of chloride deposits across the whole Martian surface. The researchers were able to learn a lot about the water that caused these deposits by analyzing them. For starters, it's reasonable to assume that the planet's final liquid water would have accumulated at the bottom of basins when they dried out. However, this is not the case in this instance. Instead, many were found in relatively narrow channels, with deposits that were generally higher in elevation than surrounding basins. This suggested to Leask and Ehlmann that the water had poured through channels but dried up before reaching the basins it had filled. The absence of salt deposits in the outlet channels from these basins lent credence to the theory. Another characteristic discovered by the researchers was that the deposits were quite thin. While getting an accurate depth from orbit is challenging, the team was able to approximate where impact craters interrupted the chloride deposit in a few cases. These discoveries all pointed to shallow salt deposits that were less than 3 meters deep. While this still implies a large number of cycles of water flowing in and drying out, Mars definitely does not require the long-term water occupancy that causes Earth's salt deposits to form. Finally, the scientists look at how old the salt deposits were. This is usually done by counting the number of craters in the deposit and assuming that they formed at a consistent rate over billions of years. However, because the majority of salt deposits happen in small channels, these aren't many big surfaces on which to compile a reasonable crater count. Instead, the scientists concentrated on the dates of underlying rock layers, which indicate a maximum age for the salt put on top. In one instance, scientists discovered a salt deposit on top of a 3.3 billion-year-old rock that had been affected by a 2 billion-year-old event. In another example, salt deposits were found on top of 2.3 billion-year-old volcanic deposits. That's a lot more recent than many earlier predictions for when Mars became too cold and lost too much atmosphere to support liquid water. However, Leask and Ehlmann did not believe these deposits indicate a continuous presence of water. Instead, they believe the water reached these routes as a result of seasonal melting of local ice formations, and that it may not have entered the neighboring basins in considerable numbers. They also point out that the location with the largest salt deposits is also where climate models suggest it would see the most precipitation if Mars had a water cycle. so there's reason to believe there could be significant ice deposits in the area. No single study will be able to provide a complete picture of Mars's wet past. Individual discoveries, on the other hand, can provide a look into different eras, providing puzzle pieces that can eventually be placed together to build a larger picture. Do you think NASA can finally reveal the truth behind life on Mars? If so, do you see a normal life on the red planet rather than worrying about aliens' existence now that we know water existed? Comment below. If you enjoyed this video, give it a big thumbs up, subscribe to our channel, and hit the bell icon to never miss an update. Thanks for watching. Goodbye.